Okay, so you should be on page 12. We need to finish up section 9.2. Last thing we need to talk about is the difference between a hypothesis test and a confidence interval, when we would use each one, and what kind of information a confidence interval gives us as compared to a hypothesis test. So, top question, can you use confidence intervals to decide between two hypotheses? So, what I'm really asking is it possible in some cases to use a confidence interval instead of a hypothesis test? And yes, it definitely is. You can when you are doing two-sided tests. So if you have a two-sided hypothesis test, you can answer the same question using a confidence interval. Now, if it's upper or lower-tailed, no. So if you're doing an upper or lower-tailed test like the one I have written on the board, mu is greater than 85,000, you can't answer that using a confidence interval. You're going to have to use a hypothesis test. Okay. Why do you think we would choose to use a confidence interval instead of a hypothesis test? What benefits, there's two I can think of, do confidence intervals provide as compared to hypothesis tests?
You have like an interval of like where it would be, like where the population.
Yeah, exactly. If we do a hypothesis test and we end up rejecting the null, do you know anything about the population mean, for example? Not really. You know whether it's greater than or less than some number, but you don't have any other information besides that. So that's what a confidence interval does, is it gives us added information. It gives us an estimate. So why would we use confidence intervals? Confidence intervals give us more information. Okay, so real statisticians, normally what they'll do is they'll carry out a hypothesis test. If they reject the null, they'll then construct a confidence interval to give them an estimate of where that population parameter is. This is something we've done before. So if we look at the next example, do you guys remember the previous problem we did, the hypothesis test that had to do with Benford's law and financial fraud, saying that if we look at a bunch of different financial investments or records, about 30% of the numbers should begin with the digit 1. And if it's radically different from 30%, then we think there might be fraud or we need to do a further investigation. Do you guys remember that? Okay, and we got a p-value of 0.005, and we ended up rejecting the null and saying the AJL and Associates firm should do another investigation or a more thorough investigation. Okay. So then what I did is I constructed a confidence interval using that same data. So a 95% confidence interval for the true proportion of expenses that begin with the digit 1 for the company in the previous example is 0.18, 0.274. Does the interval provide convincing evidence that the company should be investigated for fraud? So again, about 30.1% of the numbers should begin with a 1. So based on this interval, is it reasonable to believe that about 30% of the numbers begin with a 1? No. So does the interval provide convincing evidence that the company should be investigated for fraud? Yes. Yes, because 0.301 is not in the interval. So what that means contextually is that 0.301 is not a plausible value for the proportion of expenses beginning with the digit 1. You guys remember doing this before, right? This is exactly from the last chapter. Okay. So in your homework tonight, I believe there is one problem where you're going to have to construct a confidence interval and then answer a question based off the confidence interval, which again is exactly from what we did last chapter. Do you remember how to use the calculator for a confidence interval? No? So we should probably review that. You guys should be able to answer my question though. Can you use a calculator for the entire do step of a hypothesis test or a confidence interval? No, definitely not. Okay, so what you're going to do is you're going to do stat and you're going to go over to tests. We are not doing any tests, we are constructing an interval. So you are going to go down to 1 proportion z interval. X is the number of successes. So in this case, it says a random sample of 300 expenses results in 68 that begin with the digit 1. So X is 68 successes, N is that 300, 0.95 is what we just did, and this is the same confidence interval I just gave you. Refresh your memory now? Okay. You can also carry out a hypothesis test on your calculator. So I'm going to show you how to do that. Again, it's just to check your answer. It's not to actually carry out the whole test. If you go to stat and you go to tests, think before you shout out, what test do we think that we're going to do? Look at all the options you have. Come on guys, let's just take a guess. We're doing a test. What is the PROP? Proportion, okay. So we have 1 proportion, we have 2 proportions. Do either of those make sense contextually with what we're doing? Yeah. Yes. Do we have 1 proportion or 2? 1. Yeah. You're going to go to 1 per. Remember how I said before, the calculator for proportion will always say PROP? That if PROP is not there, it's mean. Okay, so in this case, that P naught, that comes from the null hypothesis. So our null was 0.301. Again, 68 out of 300. This was a two-tailed test. So you'll hit that, and then you'll hit calculate. Calculate gives you a test statistic, and it gives you a p-value. So that is to check your answer. For fun, if you also choose draw, it'll draw the normal curve that I have you all draw. Except I have something in y equals. Yeah, there you go. Okay, so that is to check your answer only for both a hypothesis test and a confidence interval. Questions?